All right, so what I want you guys to do is, and you could just kind of sketch this out. Let me just do this way. Start and so just kind of sketch like an XY plane on your paper. And we'll label that, of course. When we go to label this graph, though, I want to point out a couple of things. Like, this is the positive x direction, and this is the negative x direction. This is the positive y direction, and this is the negative y direction. And so this is a vector, all right? And we kind of talked about this before, but this vector represents a magnitude, but it also has a direction, okay? So there's a couple different ways we can measure that, but it definitely has a magnitude. Let's just say the magnitude of this is 5 meters per second, okay? So imagine this is like the ground, right? So you got to think in terms of like in real life. So this is like the ground. Okay, this could be like your t-shirt that we're launching out of the cannon, all right? So this is like the ground. The sun's up here, shining brightly. Okay. This is like a light blue sky. This is kind of silly now. Okay. So there's some clouds in the sky. And over here is, over here, we got to do orange. This is us. And we're all standing around. And we're shooting the t-shirt. All right? Okay? And so, in order for us to make our predictions, we're going to have to separate the motion of this t-shirt. Okay? So this t-shirt leaves the cannon at 5 meters per second. So I've got to figure out what that means, okay? So I'm going to separate this motion. I'm going to separate this motion into two vectors, okay? So I'm going to separate this in the x vector, right? I'm going to go in the x direction. And then I'm also going to separate this vector in the y direction. Okay? Now I happen to know off the top of my head that this measurement here is going to be 4 meters per second. And I also happen to know that this measurement is 3 meters per second. So if I break down the vectors, I can find out that even though the t-shirt is leaving the cannon at an angle at 5 meters per second, I can mathematically represent and figure out the directions. So I would say that this is my velocity in the x direction, and then I would say that this is my velocity in the y direction, And then lastly, this is my velocity. Does that make sense? Now, most of the time what happens when you go to do this is they don't give you this, right? Most of the time you don't have this. On most of your homework problems that we're going to do at first, you're going to have these two items and you got to figure out what the resultant vector is. But at some point you're going to have to know how to break it down into the x and y direction. Well, what's the relationship between those? Well, this is a triangle, right? It's a right triangle. Isn't there a thing called, well, I know when I say it, you can finish it for me. What's that one thing? A squared plus, anybody know the rest of this? Yeah, Pythagorean theorem, a squared plus b squared equals c squared. So that's the mathematical relationship. I'm jumping ahead a little bit, but I want you to understand vectors. Now, another thing about vectors, so does everybody have this written down? Or are you still drawing the sun and the clouds? You guys know you don't have to draw the sun and the clouds. I was just being silly. But if I grade your notes and I see sun and clouds, I'll keep that in mind. Maybe give you an extra point or two that way. Okay, so now we have to, there's some math behind this. All right, so there's one little thing I want to add to that. And the other thing I want to add is, are we done with this, or do you need a second to finish writing this down? Can I move on to another slide? Okay. So when we measure motion, whoops, not that one. This one. So when we have a vector, and we'll do red, and I go, whoops, well, that's not what I wanted. When I have a vector like this, bless you, and think of it like this. Well, this is my 0 point, and I've gone 15 meters this way, right? This is the positive direction. This is a negative direction. But then I go this direction. Well, how far, you ask? 8 meters. Okay. Here's the thing I want to point out. If I say what's the distance, you're just going to add it up. I went 15 plus 8. That equals 23 meters. If I say to you, what's the displacement? Displacement is a vector. So the direction matters. Well, displacement is saying, where did I end up? Where did I end up? So displacement has a tendency to focus on where you start and where you finish. I mean, distance does too, but not really. Distance just measures how far you go, right? Yeah, go ahead. Yeah. So I went 15 units in the positive direction. So think of this as a positive 15, right? And then I went 8 units in the negative direction. When you do the math on that, you get 7 meters. That's where I ended up at. Okay? That's where I ended up at. So when we talk about speed and velocity, right? Displacement, when we do velocity, that's displacement over time. When we do speed, that's distance over time. Now, you can do both. There's a time for both. Okay? But that's what we're going to do in today's assignment. Okay? Any questions? All right, give me 2 seconds and I will post your assignment.